And thanks, Lorenzo, for the kind introduction. Good morning, everyone. Thanks for being here. I'm Alessandro from Iteco. Don't get confused. There are actually two of us. You can refer to me as the younger one. And, today we'll be exploring how to troubleshoot Janus-centric WebRTC application by means of admin API and event handlers. There are two tools that take different approaches to this problem, but they share the same purpose. We see what does this mean. First, I want to share with you some thoughts about WebRTC. This is me. When I started learning WebRTC during my last year at the university, I was preparing my master degree thesis, and I soon discovered that WebRTC is amazing technology to work with. It was pretty easy to code simple examples like simple peer-to-peer application where browsers just talk to each other, and it was basically my thesis. And there is also a lot of documentation available online from different sources. This admitted that you're that kind of guy and not this kind of guy. And I was that kind of guy, but I'm trying to improve on this side. All of these good aspects make me approach more complicated problems with the best intentions, but I have soon discovered that it's also very easy to make unreported mistakes in WebRTC, and you could end up feeling like this, that you don't understand what's going on in your code, and it might reveal a true pain to troubleshoot if you don't know how to properly use the appropriate tools. So you might end up spending way more time debugging your code than writing it. And this brings me to the next point of my presentation, how we can troubleshoot today a WebRTC application. It is well known, for example, in browsers like Chrome and Firefox, that we have some tools out of the box, like the internals of the WebRTC panel in Firefox. Unfortunately, we don't have the same luck in Safari and Edge. Hopefully, Edge, Chromium-based Edge will change this. Anyway, you can still rely on the well-known WebRTC API like GetStats to create some custom toolings for troubleshooting, like, for example, Philip Anke made with WebRTC externals. Meanwhile, for native applications, this is up to the implementation and often tied to the core library you're using for WebRTC. But what about the server? We know that many applications involves server in WebRTC. What about in this case? We know that we need the more the logs. The more the logs we have, the easier is our job, right? So what about the server in discussion, Janus? Well, it turns out that we have not only one but two solutions for troubleshooting, and namely these are the admin API and the event handlers. And I'm going to speak about the first one. The Janus Admin API is a very simple request-response protocol that is exchanging JSON payloads, and it does use the same transpose as the Janus API, so HTTP and WebSocket, or also Unisockets and NanoMessage for inter-process communication, and ANQP and QTT for middleware-oriented messaging systems like RabbitMQ. And you have to remember to enable in the specific transport configuration the admin API to make it available to the users. This is an overview of what are the features of the Janus Admin API. You can, for example, get some information on the Janus running instance to also get on set some options. You can have some insights about ongoing user sessions and user handles. You can list them, destroy them, or also get some status about the current state. You can also manage the tokens for the access to the Janus API, and also you can interact with the plugins by dispatching message to specific logic plugins. This is a sequence diagram showing basically how you can interact with Janus through the admin API during the life cycle of a user handle. In this case, you can just poll the admin API to get information in different times of the handle life cycle. Now, this is time to show you how we can enable the admin API. So I'm switching to this screen, and we head to the Janus folder where we have the configuration of Janus. First of all, we need to set a password for our admin API. In this case, I'm leaving the default one, that is Janus Overlord. Then as I said, you have to modify the configuration on the transport you want to enable the admin API on. In this case, I want to pick the HTTP transport, and heading to the section named admin here. You can basically enable the admin API through HTTP by setting this flag to true, and you can also set the port and other fancy settings that has been documented on Janus documentation. Once we have this, we can just start our server. And for sake of simplicity, I'm gonna use the admin web page that we provide on the Janus repository to get information for the admin API. Basically, this is a page that is polling the admin API under the hood by doing simple HTTP requests. And as I said, we can see how can we get the information on the running instance, like, for example, the version of the server and the name of the instance, the local IPs and things like this. We can get the settings of the server and also set them on runtime by using always the admin API. And also we have information on running sessions. This is of course 0, no one is on my local server. And now back to the presentation. Not all the features of the Janus Admin API are useful for troubleshooting, so just some of them, and we're going to see some example of how to use them. Now, I'm very sorry, but I have to show you some JSON dumps. This is the most important message for the Janus Admin API. It is called handle info, and it basically just pulls the status of the current ongoing handle, where you have to pass in this message the identifier for session and handle, and also you have to specify a transaction ID, and this is very useful for that kind of transports where the request and the response are not obviously correlated. This is not the case for HTTP, but this might be the case, for example, for inter-process communication. And when you have the response from Janus, there is the actual payload in the info object, where you have a lot of information. For example, you can get the name of the plugin that responded to you, some specific information on the internal status of that plugin, and opacity to help correlating handles coming from the same user session. Then we have some Boolean flags for the internal states, SDPs that are basically the JSAP offer and answer for that handle, and then the streams object, that is basically everything related to WebRTC for that handle. Now this is a public service announcement. We have a unified plan branch that will be merged sooner than later. So once this merge has been concluded, the streams object will be replaced by the WebRTC project. And in this object, we have rearranged all the data inside handle info response in, let's say, a better way, in my opinion. And obviously, we had to cope with unified plan by splitting information from media IDs. And now I want to show you some real-world cases where the admin API proved to be really useful for troubleshooting. This is the case number 1. We're dealing with EchoTest plugin. For those of you who are not familiar, it's a very simple application in Janus where the user starts a session and Janus sends its media back. And the symptoms in this case are that the application seems indefinitely blocked, and there's no media, and also we have no errors on the browser. This is what the user is viewing on his browser by using the Janus EchoTest web page. There is a spinner going. And in order to troubleshoot, we need to gather the session ID and the handle ID, and to get this information, we just inspect the browser console or the network panel. We have many ways to get that information, and then we just create the handle info by using a command line tool like curl, or simply getting it in a Janus Admin API demo page like I showed before. Once Janus has the response for the handle info in this case, we may notice in the flags section that the flags got offer and got answer are false, and also the sections STPs is void. This means that basically Janus does not know anything about JSAP negotiation for this session. And we have diagnosis for this case. The application is not sending any JSAP offer to to Janus, and very likely this is a bug in the web app, and it really was because I forgot to uncomment a line in the JavaScript. So this is solved. Case number 2, we're still dealing with the same application, the EcoTest plugin. The symptoms are again no remote video, but this time after some time, let's say after 15 seconds, the connection gets closed by Janus. So no video, and after some time, the connection gets closed, and then a pop-up is notifying us of this fact. Troubleshooting with handle info, again, now we have the flags about the negotiation in the correct way, so everything is true. We can see also the local and remote JSEPs in the response. So we have to drill down in the Janus response, and we're focusing on in the stream section, in the part relative to ICE. We can see that the state is still connecting, and we have a bunch of local candidates and remote candidates, UDP candidates. Also, we have some public IP get through the usage of a stand server. But this is not working. Why? Well, maybe this is one of the cases where we have to blame the network. And if you remember the amazing talk by Alessandro from yesterday, one of the worst enemies in ICE process is the NAT policy. Clearly, I'm talking about symmetric NAT, and we're lucky because we have a specific message on the admin API to understand what is NAT policy on Janus, and in order to do this, you just send the same stand check through the admin API to different server by using the same local port. And this is a very recent announcement we made to the test stand message on Janus Admin API. Hopefully on the response you get from Janus, you will have the same public IP but different public ports. And this means that basically you are behind a symmetric NAT. And we have diagnosis also for this case. The ICE process is failing. This is clearly a connectivity issues, but just being behind a symmetric NAT is not an issue per se. It must be coupled with another restricted NAT on the other side, or maybe the connection is hitting a firewall along the way on the client or on the server side. We can try some possible solutions. We can check the Janus port range, or maybe the NAT or firewall settings on the Janus source. This is especially true for deployment in the cloud or in containerized instances. Or we can try enable return on the client, for example. And so maybe we have not the right solutions, but we were able to find the root issue of this case, and so we can mark this as solved. Case number 3, we switch into another application. It is the streaming plugin. And for those of you who are not familiar with this, Janus is just relaying an RTP source coming from a FFmpeg or GStreamer pipeline or another process generating RTP, and then it's relaying this stream through WebRTC to the client requesting it. We had the same symptoms as before. There is no remote video and no errors on browser console. So again, the user is viewing this troubleshooting through the admin API. We see now that we have local candidates and remote candidates. So we have a selected page section. So this means that the ICE agent of Janus has been able to find a working page in the ICE process. And also the DTLS has been established. So everything seems okay from the connection point of view. And now, heading to the out stats, there's something strange. We can see that there are no audio bytes and no video bytes. This means that Janus basically is not sending anything to our client in the streaming plugin. But given that Janus is just relaying what is receiving from the RTP source, we may ask, is the source sending any media? Again, we can troubleshoot this by using admin API by forwarding a specific message to the streaming plugin. And this message is the request info. And I want to say that this is a custom syntax for the streaming plugin. It is only valid for the streaming plugin, but through the admin API, we can send specific message to specific plugins. So once the streaming plugin has an answer for us, we can see that we have the 2 attributes down in the JSON, audio and video age milliseconds, and this basically means that the last time we received an RTP packets from the source was 75 seconds ago. Again, we have a diagnosis for this case. The ISDTLS has been successful. Media not flowing because the RTP source is not feeding Janus, the Janus mount point. So Janus is not interrelated to the clients. We had to check the media source. We had to check the process we are using to generate the media source in this case. And this is solved. We have now a variation on the previous case, the case 3B. We're still dealing with streaming plugin. This time we had some video quality issues, like freeze or blocky videos. Troubleshooting with Admin API, again, we see that the out stats now are very good. We are just giving the user some bytes of audio and video also in the last seconds. So this is working. But what about the instats? What is receiving Janus from the client? We can see there are a lot of video NUCs from the clients. So this is something we need to check. And going in the RTCP section of the Admin API, this looks confirmed by the loss by remote attribute that says basically that the RTCP is a message where there is an indication of lost packets from the clients. And also we have an index called outlink quality that is an index that has a maximum of 100. In this case, it is well below the maximum value. So this is clearly a packet loss. But this is just half of the picture. We need to understand where this packet loss is occurring. It might be the channel between the RTP source of Janus, or maybe the channel between Janus and WebRTCP. And we need to discover this thing. So we again use a specific message directed to the streaming plugin called recording start, where we just start the recording and we tell Janus where to put this recording, so audio and video streams. So we are recording on the left side of the graph. We are taking recording in the inbound traffic. Janus, so we start the recording in our custom MJR format, and the MJR files can be analyzed with at least two tools. The one is the post-processing tool. The other one is MJR to pick up that just convert the MJR in a packet capture. So you can just analyze it with Wireshark, for example. So let's say we have our recording. We have analyzed it with the post-processing tools or the MJR to pick up tool. And we have concluded that there is a packet loss in the RTP source. Possible reasons for this are a lossy or a congested network on the source side, or maybe the encoder is under heavy load, so it's just dropping some packets. And we can mark this as solved. Final variation on the previous case, still streaming plugin, again, no remote media. Troubleshooting this, we can see in the inbound stats that now the number of video NUCs is not so relevant. The out stats is okay. Video bytes also in the last seconds. RTCP stats indicate very low loss. So in this case, we need to go deeper, understand what's going on here. Maybe we can just do a packet capture here that might be of help. And Janus can be requested to start a packet capture on a handle. This packet capture can be done in both a binary or text format. And just remember that this capture happens at RTP level, so any network headers are fake in the final file. So IP addresses and ports will not match the real IP addresses and ports. And this is the message on the Janus Admin API to start a packet capture. In this case, I'm starting a binary capture. Again, we have to specify the folder and the file name. This is different from the previous scenario. We are capturing on that side, on the right side of the graph, and you may wonder why we did not use the same tool as the previous scenario. The truth is, yes, we could have used the same recording capability, and probably we would have ended up with the same conclusions. But there is a big difference from the two features, because the handle packet capture is a core feature and not a specific plugin feature, and does not involve a specific plugin syntax to be executed. And you could be able to troubleshoot in this way any Janus Placet application, not just a streaming plugin. And finally, you can have perspective of the issue from the WebRTC client perspective, and not from the inbound traffic perspective. So let's say we have our packet capturing in a binary format. We have analyzed it with Wireshark, and we concluded that the bitstream has something wrong. What are the possible reasons behind this? Very likely this is an issue with the RTP source. For example, we set the wrong codecs in the encoders. Janus is expecting a VP8 video, for example, and we're sending an H.264 video. Or maybe we have inverted audio and video destination ports, and this is a true story because it happens often to me when I work with Janus. And so we can mark this as solved. Now, let's jump to the event handlers. Admin API is a cool feature, and historically it has been the best, if not the only way to troubleshoot Janus applications in a fast way, but it has some downsides. For example, it needs polling to implement session monitoring, and information about the user session gets lost when the handle is gone. And the info in response might also be redundant in some cases. You might just need some parts of that response, not all the parts. And for these reasons, we developed in 2017 the event handlers that they implement an asynchronous approach to troubleshooting, where basically Janus core and plugins generate events in JSON format and tagging them with identifiers to allow filtering of those events. And these events are propagated to local events handlers, and every handler just manage them in a custom way with a custom logic. They, for example, might save them to a database, save them to a file, or also send them to an external service. This is a sequence diagram showing how the event handlers basically works, the core, and Janus plugins are emitting some events. The events manager, that is still part of Janus core, just iterate over all the local event handlers, and every single event handler that has subscribed to that event then do its custom logic. Some of them may send them on HTTP, some can, like I said, can save them on a database. And we have many event types on Janus. Some of them are dealing with core events like the process up or down. Some of them are related to session or handle that the user is establishing. Some are about JSON negotiation or WebRTC status changes, or also media events about the media start or stop flowing, also statistics about those medias. Then there are specific plugins for specific events for custom plugins, specific events for transports. Finally, external events that are basically events forwarding through the admin API. This is a format of an event emitted by the Janus core. We have an attribute specifying which Janus instance emitted this event. This is very important in case you have a collector that is handling more one Janus events. Then we have identifier for the handling session that emitted these events, and OPAC-ID that has the same semantic as the admin API, so it's helping correlating different sessions coming from the same users. A type identifier specific for every kind of events, and then we have the actual payload, where the syntax is different for any kind of event. In this case, I picked the selected pair event that is notifying an handler that Janus, the IS agent on Janus has selected a working pair. And we can see that in this case, we have the local and remote candidate that compose this working pair. The sample event handler is a proof of concept you can find on Janus codebase, and it provides a very simple event handler that just forwards the events via HTTP to a web server and supports basic functionalities like authentication and grouping of JSON events, and also supports simple retransmission with an exponential backoff. When dealing with the sample event handler, basically, as I said, when any event gets forwarded to the web server, you have to configure in the sample event handler configuration. And this is going on for every kind of event we are subscribed to. Then we have another particular kind of event that is the periodic media statistics event. It's very important because it's a event automatically emitted by Janus Core for active peer connection by default every second, and it has some very useful information about the status of an active peer connection. The payload is very similar to the admin API and the info response, at least the part about the media statistics. Again, this is its format. It's very, like I said, it's the same format of every generic event coming from Janus. The type is 32, and this is the payload. We can see that we have many information about round trip time, lost packets, jitter, byte sends, packets received, and things like this. Very useful to have an idea of a life cycle of the handle. And I just mentioned it before that you can subscribe to specific events when dealing with the event handlers. And actually, the event handlers may subscribe to different event types by setting what is called a filtering mask. This mask can be changed in the configuration for every single event handler, and can accept special tokens like all or none. Can also be changed at runtime by using the admin API. The syntax to execute this change at runtime is defined in the single event handler implementation. So I have here an example of how we can change at runtime the filtering mask of the sample event handler. We can see that this is a message for the Janus Admin API, and the type is query event handler. And in this case, we have to set a request tweak, and then we pick the events we want to subscribe to by just setting them in the message with a comma-separated fashion. And this is now a demo for how we can enable the sample event handler. First thing, again, add to the Janus main configuration. And go to the events section, where we need to enable the forwarding on the events from the core and the plugins. And we also change the stats period to 5, just to not spam my console. Then heading to the sample event handler configuration, we enable it. We are subscribing to all the events with the old token, enable grouping, and also we can set the backend where the events must be forwarded. In this case, I am forwarding it on the local host, so I'll be needing a web server. Starting Janus, saying an error because there's no web server. I'm starting a simple web server now, just to get the process up event. Okay, this is the fun of the live demo. Anyway, I'm sorry, I'm running out of time. I want to thank you for your attention. I want to conclude with what is my working life at Mitego, and what is my reason to use the troubleshooting on Janus, and that is to try to win an argument with Lorenzo. Thank you for your attention.
Thanks, Alessandro. And their JavaScript usually sucks. Do we have any questions for Alessandro?
Vuoi usare il portatile?
Do we have any doubt? Maybe some quick question that you have? I see somewhere there.
Hi, I'm interested in the RabbitMQ transport. So with RabbitMQ, how the configuration will look like?
You want to see the configuration for the RabbitMQ renderer?
Yeah, right.
Yeah, it's very simple. It's very basic. You need to specify the RabbitMQ server and the name of the queue you want to use for pushing and getting the events. It's like that. We have not that. I could say it's very basic. So you can just take the configuration that is on the source repository, and yeah, everything is commented, everything is documented. It's pretty simple.
Okay, thanks.
Saul?
Hey, thank you for an amazing presentation, by the way. Any particular set of event dedicated to SIP?
SIP?
Yeah.
Yeah, the SIP is a custom plugin in Janus. So yes, every kind of information about the SIP can be found in the plugin-specific object in the Admin API, or also about event handlers. Yes, there are many events generated from the SIP plugin you can use to troubleshoot your SIP applications. So you have to read the documentation of the SIP plugin. There are many events generated from that specific plugin.
Yeah, in the VI event handler specifically, if you use a customized version of Sophia SIP, because we need to have access to the actual payload of the messages, and we can only do this with a custom change, you can get all the SIP messages that have been sent and received on each handle. So yeah, so basically you get the events on all the SIP messages, and so you can actually reconstruct the dialogues for that specific handle if you captured all the events. Sorry? No, I mean, this is just for how it is today. So
by the way, this is the demo I want to show you. This is the web server that has got the event about Janus process going up. Started. Then I want to start a echo test session here. And these are all the events emitted from the echo test. And we can see the media statistics events that is emitted every 5 seconds here, that has all that information I was talking before. Okay. Thank you.
okay, thank you, Alessandro. Okay, now we pass the floor to